So this first problem is a central limit theorem problem for sample means. It says, according to a recent report, the mean time spent on smartphones daily by American adults is 2.85 hours, with a standard deviation of 1.4 hours. Given this information, explain why we cannot find the probability that a randomly selected American adult spends more than 3 hours on their smartphone daily. I know that many people would wonder, well, why don't we just draw a picture? So, draw a picture of a normal distribution and then put the mean and the standard deviation and then, shade an area and use a normal calculator. And the reason we cannot do this for this problem is we don't know the population is normally distributed. Because the only way we've been able to do these types of probability problems is with normal distributions, and if you read the setup, nowhere does it say the population is normal, so we can't do part A. But suppose we take a sample of 40 American adults, measure how long they spend on their smartphones, and find a sample mean. Explain why we can find the probability that the sample mean is more than 3 hours, and then find the probability. So we're being asked to find a probability involving a sample mean. And so the question is, can we apply the central limit theorem? Well, remember, we can apply the central limit theorem if our sample size is greater than 25. And here we have a sample size of 40. So since our sample size is greater than 25, we can apply the central limit theorem. And what does the central limit theorem say? Well, the central limit theorem says that you ask these 40 people how long they spend on their smartphone, and another sample how long they spend on their smartphone. Each of those sample means may vary from sample to sample, but the central limit theorem tells us that the variability is predictable. The sample mean distribution will have a shape that's approximately normal. The center will be the same as the population mean, and the population mean we were given is 2.85 hours. And the spread, or the standard error, is given to us by the formula sigma divided by the square root of n, where sigma is the population standard deviation. So we would have 1.4 divided by the square root of, and our sample size here is 40, and so this distribution would have a spread of 1.4 divided by the square root of 40, or in other words, 0.22. So now we have a picture of the distribution. We can find this probability. We want the probability of a sample mean more than 3 hours. We simply need to find this area under a normal curve using a normal calculator. And so remember, we do that using StatCrunch. So we'll come to StatCrunch. We'll come here to our calculators. The one we'd like to use is our normal calculator. Okay, so the mean is 2.85. The standard deviation is 0.22. And we're being asked to find the probability of an x value greater than 3. All right. So this corresponds with the picture we'd drawn. And so the area is 0.249, or about 24.9%. So this area here is 0.249, and so the probability is 24.9%. Could we find the probability that the sample mean is more than 3 hours if the sample size is 10? Why or why not? So remember, in order to apply the central limit theorem, you either have to have a sample size greater than or equal to 25, or you have to know that the population is normal. The way you know the population is normal is because it will say so in the problem. If you come back here and read the problem, nowhere does it say the population is normal. So we don't know the population is normal. And our sample size in this case would not be greater than 25. All right? And so since neither of those conditions is satisfied, we cannot do this problem. Why not? Because we cannot apply the central limit theorem. And so that's a review of the central limit theorem for sample means. Because these videos have to be short in order to upload to YouTube, I'm going to do a second video for the next problem.